Good day and welcome to the Math Salon. I'm Dr. Anumenem. Today we are going to look at the general quadratic equation formula and look at the discriminant. This is a very important formula, and the technique we use here can be applied in all domains, nearly all topics in mathematics, additional math, advanced level mathematics, and further mathematics. So it's important that we look a bit into this form. Other videos will come just taking the technique and applying them. So I would advise you to watch this video closely. So just imagine you were asked to solve this quadratic equation. It's a general quadratic equation with general coefficients there. Then the key technique that we can use here, if we did not yet know the general quadratic equation formula, is to apply completing the square method. We already indicated, I told you in the past, that to complete the square simply means writing it in the form x plus a to the power 2. That's the idea. So let's have a problem written here. So this x squared plus bx plus c is equal to 0. In order to use the completing square method, it's important to have the coefficient of x as 1. To do that, I will just divide all through by a. If I do that, the mathematics is still correct. It's sounding. I've done that overall, so the equality still stands. But again, that the a here goes away, and I have x squared plus b on a, x plus c on a is equal to 0 divided by a is 0. To complete the square, it's important to take this constant away so that I decide which constant I want to put here so that the square is complete. To do that, I have x squared plus b over a, x. I keep some space here to fill in what I need to plug in so as to get the square completed. And I take this to the right hand side and it becomes minus c on a. If you expand this, you will see that this is x squared plus 2ax plus a squared. And if you look at this very well, this is just half the coefficient of this. So that's actually 2a on 2. That's actually that squared. So I'll try to do that here. So if I take half of this coefficient and square it, then this 3 terms will be the term for a completed square. So this will be here b divided by 2a, all that squared. That's half of this. Half of this means 1 and 2 multiplied by that. But I just added a term that was not there. So this inequality is not correct anymore unless I take it away. 2a, all that squared. But by so doing, this part now is a completed square, and that is x this term, and this one inside here, just like this one inside here was there. So b on 2a, all that squared, minus this squared is b squared divided by 4a squared. That's the square of that. Can take this to this other side. Remember, this minus c on a. If I do that, then I get x here plus b on 2a squared is equal to b squared all over 4a squared minus c on a. It was minus. When I take it to the right hand side, it becomes plus. And look for the lowest common multiple of these two. Actually, this is just 4a squared. 4a squared can divide this and it can divide that. So I can write there 4a squared. 4a squared divided by 4a squared is 1. 1 times b squared is b squared. Minus, this minus there. 4a squared divided by a, this a will cancel one of the a's and I'm left with 4a. 4a times c is 4ac. So just to move up here, that means we now have that x plus b on 2a, all that squared is equal to b squared minus 4ac all over 4a squared. Remember, the intention was to solve for x, to get x value. I have x here still within the square bracket, so I'll try to do away with that. One way is to take the square root of both sides. If I take the square root of this side and the square root of that side, this square root removes that. And I get here x plus b on 2a is equal to, this square root I will put plus or minus. Why? Because if I take the square root of 4, the answer you will surely say is 2. But I also know minus 2 times minus 2 is 4. So this should be plus or minus 2. I can separate my root sign to the numerator and denominator. That is correct mathematically. So that's minus 4ac and the square root of 4a squared. The square root of 4a squared is, the square root of 4 is 2 and the square root of a squared is a. So x plus b on 2a is equal to plus or minus the square root of b squared minus 4ac divided by 2a. I want only x. I don't want x plus b on 2a, so I take b and 2a to the other side. So my x becomes minus b on 2a plus or minus the square root of b squared minus 4ac divided by 2a. I can put these two together. If I do that, because here they have the same denominators, so I will just say my x is equal to minus b plus or minus the square root of b squared minus 4ac, all that divided by 2a. So here we have one value, but actually there are two of them, because with this quadratic equation you should have two answers, two roots. That means x is equal to minus b, I take the plus version, b squared minus 4ac divided by 2a, or minus b minus square root of b squared minus 4ac divided by 2a. So we come to our, this is the general quadratic equation formula here, which is x is equal to minus b on 2a plus or minus the square root of b squared, minus 4ac. So that's the general quadratic equation formula that we normally use. And if at any time you can remember this, then you can solve any quadratic equation of your choice. Now, if we have that, then there's something I would like you to know about what we call discriminant here. So we now agree and have seen that the roots of this equation will be minus b plus or minus the square root of b squared minus 4ac divided by 2a. But you can only solve for these x values depending on some conditions on this guy under the square root. I'll call that guy d for discriminant. So let's say d is equal to that. So you would see that if d is greater than 0, if d is a positive number, like 2, like 3, like 4, then the square root of d exists, and it's going to be 2, plus or minus. So in that case, then you get two separate roots, one with the plus 1 and another with the x. So we get two distinct roots. If d is equal to 0, then this part is 0 and the square root of 0 is 0, and there is no difference between plus or minus 0. We still get two roots, but they are the same, they are equal. So the roots will be the same. Two roots, two equal roots, I'll just say. If d is less than 0, it means it's negative, like the square root of minus 4. In the past, you would say that, yeah, under the real number environment, you will not be able to solve that. But now at advanced level, you've learned that this can be expressed as a complex number. So if we have this, we have two distinct complex roots. So it means, given a particular question in hand, you can decide how to proceed. If you see that your discriminant is positive, strictly greater than 0, then you know that the two roots that you are going to find should be two and different, and they'll be distinct. But if your discriminant is equal to 0, it means your two roots that you have will be identical. So x is equal to 2, x is equal to 2, for example. And if it is negative, then you know that the two roots you would find would be complex. This can really be helpful, and you will see that in future videos in some problems that I saw in some past questions already. Thank you. Remember to give us some thumbs up, and please subscribe.